Apologia, 8th grade, physical science, week 3, day 4, textbook pages 48 through 53, notebook pages 48 through 51. Let's continue our module 2 discussion on matter. At room temperature, what state or phase is matter in? First, and you all know this, we have a solid, the state of matter in which a substance has a definite shape and definite volume. My computer, for example, our textbook, for example, no matter what, it is the same shape and the same volume sitting here as a solid at room temperature. Liquid's a little bit different. Liquid is the state of matter in which a substance has a definite volume. So if I look at my coffee cup this morning, we can see liquid in there. It definitely has volume. However, it does not have a definite shape. If my coffee was in a different cup or container, the shape would change to that of the container. Therefore, liquids have definite volume, but they do not have a definite shape. They can form to the shape of whatever they're in. So we have a solid that has a definite shape and a definite volume, and a liquid that has a definite volume and just conforms to whatever shape it's in. Then we have gas, the state of matter in which a substance has neither shape nor a definite volume. All right, unlike liquids, gases have no definite volume, but really what do we mean by that? Well, of course, gases have volume, but their volume changes to match the volume of whatever container they're in. Let's think of it this way. Think of helium balloons. The helium inside each balloon takes the shape and volume of the balloon. No matter what shape balloon you have, the helium will take the shape of that balloon. If the volume of the balloon changes, and sometimes this happens if you leave a balloon in a very cold or very hot area, the volume of the helium also changes inside to match the volume of the balloon. So solids, liquids, and gases are known as the 3 states or phases of matter. And I would say they're probably the most common 3 states or phases of matter as well. Maybe something else to mention now about gases. Gases are less dense than liquids. So maybe we need to talk a little bit about density. Density is defined as the ratio of a substance's mass to its volume. And there below we have the formula for density. Density equals mass divided by volume. All right, we actually do have a 4th state of matter, a 5th state of matter as well. But let's talk a little bit about the 4th state of matter called plasma. So what is plasma? Although most of the matter on Earth exists in one of the 3 states we talked about, solid, liquid, and gas, most of the matter that we see in the universe exists as this 4th state of matter called plasma. The 4th state of matter exists where temperatures reach millions of degrees Celsius, such as in our stars or our sun. All right, kinetic theory of matter. Let's go back and define kinetic energy, energy of motion. We've learned about that for many years. Objects that move faster have more energy than objects that move slower. So the faster an object moves, the more kinetic energy it has. The kinetic theory of matter states that all particles of matter are in constant motion. So this coffee cup, this solid, is in constant motion, moving very slowly, but everything is in constant motion. The particles that move with greater energy as they become warmer, and that particles move with less energy as they become cooler. So let's briefly talk about figure 2.4, particles and the states of matter. Solid particles vibrate around fixed positions, but do not move within the substance. That's in a solid. In a liquid particles vibrate and are free to move around each other. Gas particles are in constant random motion. You may not think that the particles making up solids move at all, but like I said in the last slide, everything moves. Now, the particles that make up a solid, whether they're molecules or atoms, they're not free to move throughout the solid, but they can each vibrate back and forth or up and down around a fixed position. Think of it sort of like a movie theater. There you go, look at the little visual. Or an auditorium or something like that. You can think about this like an auditorium full of people all sitting in their seats watching their movie. Each person is in a fixed seat and does not move from their seat during the performance. However, each person is free to shift positions within their seat. This is similar to how the particles of solids move or vibrate without changing seats. The particles of a solid have a small amount of kinetic energy because they vibrate back and forth, but their strong force of attraction keeps the particles in fixed positions within that solid. All right, moving on from solids, we have liquids. The particles in liquids have even more kinetic energy than those of solids. The particles in liquids are not as closely packed together as the particles of solids. Unlike solids, where the attractions between molecules is very strong, the attraction between liquid particles is weaker and does not prevent the movement of particles. You can think of it like a race. All of the runners are moving, but a runner's path may be blocked by the position of other runners around them, and so they may group together for a time, but then after a bit, the group breaks apart. This is similar to the behavior of liquids. There is sort of a tug of war in liquids between the constant motion of the particles and the forces of attraction between the particles. Generally, liquid particles have enough kinetic energy to keep from being held in a fixed position, yet they do not have enough energy to free themselves from the forces attracting the particles to each other. This tug of war explains the behavior of liquids. So a liquid has a definite volume because forces of attraction keep the particles close together. However, a liquid does not have a definite shape because particles in a liquid have enough kinetic energy to flow to new locations around each other, which is why a liquid takes the shape of its container. All right, lastly, gas. Gas particles have the most kinetic energy and are always in constant random motion. In fact, at room temperature, gas molecules can move on average 990 miles per hour, but they rarely travel very far because they are colliding with each other or the walls of their container. After a collision, the particles go off in other directions. Because the particles are moving so fast and moving apart after collisions, the attractions between the particles are too weak to have any effect. And in fact, under ordinary conditions, scientists totally ignore the forces of attraction between the gas particles. You can think about the movements of gas particles like a bouncy house. Notice how there's a lot of room between the bouncers, and they can each bounce anywhere within the walls of the bounce house. If they bump into each other, they will each move away in another direction. This is very similar to how gas particles behave. Even though there are many, many gas particles in a given space, the particles are so tiny that over 99% of the volume is empty space. Because the particles of gas are in constant motion, the gas is able to spread out and fill a container of any shape or size. So gases have no definite shape and no definite volume of their own. The last definition I think we should talk about is diffusion, which is the natural passive movement within gases and liquids that spreads out particles from an area of higher concentration to an area of lower concentration. Diffusion occurs in both liquids and gas particles because both are constantly in motion. Diffusion, however, occurs faster in gases than in liquids. All right, on your own, let's get these last couple questions answered. On your own 2.4, explain how shape and volume are used to classify solids, liquids, and gases by matching their terms to their description. So a solid is a substance that has a definite shape and a definite volume. A liquid is a substance that has a definite volume, but takes the shape of its container. Don't forget my coffee and my coffee cup example. And then a gas is a substance that does not have a definite shape nor a definite volume, but takes the shape and volume of its container. On your own, 2.5, what is kinetic energy? Kinetic energy is the energy an object has due to motion. On your own 2.6, when a substance cools down, what happens to the speed of its particles? As a substance cools, the speed of movement of its particles slows down. All right, thanks everybody. See you next week.